Did anybody sketch a picture of this? Anybody? Okay, so let's sketch it just to give some people an idea of what it looks like. And that is not what I wanted to do. Okay, let's sketch it and see what it looks like. So we have drawing the quadrants here. Nice, yay, not bad. Okay, so we have z, x, and y. So it says find an equation for the plane containing the line in the xy plane where y equals 1. So let's make that red. So let's say y equals 1 right here. So it's in the xy plane, so it looks like this. So it contains that one. And the line in the xz plane where z equals 2. So that's this one. And let's go to blue here, for example. So it's up here. Xz plane, so it looks like this. And that's not a straight line at all. It's not bad. Okay, so what is this plane going to look like, therefore? There's red or green right here. Kind of looks like this, right? There's your plane. Nice. What's the equation for a plane?
Z minus Z naught equals
M, yep. Yep. Plus n times what? Y minus y naught. So we can use any point we want. Do we have a lot of different points we could use? Sure. What point do you want to use for your initial point?
Something with zeros.
Something with zeros, exactly. So how about 0, 0, what?
0, 0, 2.
0, 0, 2. So there's our point. So we need to find m. M, what was the definition of m? dz what?
Dx.
dz dx. So that's when what is constant?
Y.
That's when y is constant. So if we keep y constant, what happens to x? Well, we need to find a position, a place where we need to find dz dx. So where do you want to start? What point do you want to start at and take a little walk? Give me a point to start at. You can start at any point you want and then keep the y value the same. So all you need to do at this point is pick a point anywhere on there.
0, 1, 0.
0, 1, 0. I like that right here. Great pick. So that's 0, 1, 0 right there. So if you walk in this direction, what's dz dx going to be? If you're a little dude walking on this line right here, yay, little guy. Look, draw a little person. Nice. If you're walking right there and y is staying constant, what is happening to your height?
Not changing.
It's not changing. So what is dz dx going to be?
0.
0. It is 0. Nice. It does not change. So then what is n equal to? What's n?
dt over dy.
N is dz dy, and that's when what is constant?
X.
X is constant. Nice. So what point do you want to start at and keep x constant? You can literally pick any point you want on here. What's an easy point to start with?
0, 0, 2.
I love 0, 0, 2. Excellent. Let's start with 0, 0, 2 right here. 0, 0, 2. Nice. So if you walk and you keep y constant, what path are you going to be on? You're going to be walking straight like this, right? So you have to find the dz dx at that instant. It's going to be flat, so it goes down. So how far down do you go and how far over do you go?
But if you go down, that way won't y change?
Y doesn't, it's when x is constant, not when y. It's x. X is constant. X is constant. So in this case, x is 0. So along that line I just drew right there, I'll draw it in purple here. Along this, sorry. It's a little easier to see if I do this. Along this, right here, x is 0. X is 0. Got it? Okay, so what is the rate of change with respect to x in terms of z? So dz dx, what is dz dx going to be? You could use some points here. You're going from 0, 0, 2. You're going from 0, 0, 2 to what? 0, 1, 0. So you want dz dx. What's the rate of change of z going to be? 2 minus what? 0 over, so that's 2 minus 0, and then what? 0 minus 1. So what's that going to be? Negative 2. So now we have our two slopes, and we have our point. So what's our equation going to be? Z minus what? 2 is equal to 0 times
X
minus 0 plus
negative
2 times
y minus
y minus 0. Right. So
Well, we have
dz
that the red.
dz dy. Yes, it should. Thank you very much. Thank you. Yes, this should be a dz dy. Correct. So what does this simplify to? Z minus 2 is equal to what?
Negative 2y.
Negative 2y. Yep, that's correct. And it kind of should make sense because look at this plane right there. Does anything change when you change x? Does the height change when you change x? No, it doesn't. So it should be independent of x. Yes, and does this plane keep going in all these directions here? Yeah, all 4 of those directions. Nice. Just sketch a few points on this. Yeah, you just sketch a few points. So telling you at any point on the xy plane, the temperature is going to be 100 minus x squared minus y squared. Great. Sketch isothermal curves of constant temperature for t equals 100, 75, 50, 25, and 0. So they're asking you to sketch this. 100 equals 100 minus x squared minus y squared. And then they're asking you to sketch 75 is equal to 100 minus x squared minus y squared. And then they're asking you to sketch 50 and what else? 25 and what? 0. So you have to sketch those. It's asking you to sketch those, and they're two-dimensional.
Yeah.
So you have to be able to sketch those. And if you're totally lost, I guess what I can tell you is this: plot a couple points. Sometimes that it helps me, Cameron. Like on those, I'm like, I don't clearly see it. One thing I did give you today, which might actually be really helpful for you, on page 671 in your book, it gives you these catalog of surfaces, which is like the general shapes for all the different general three-dimensional surfaces. Similarly, you have these right here. Sorry, I just got lost here. Like 100 equals 100 minus x squared. What's that gonna to me? 0 equals negative x squared minus y squared, right? So what does that mean? Y squared is equal to negative x squared. But what's the only point that works for? 0, 0. So you have, well, it's 1. There you go. You got your 1 point right there. Dot. And then you have, what's the next one? Negative 25 is equal to negative x. I wish I could write today. Negative x squared minus y squared. So 25 is equal to? So what's that? Yeah, but what shape is that? You need to know what that is. Circle with radius. Yeah, that's a circle with radius 5 around the origin. Right. So then you start noticing a pattern here. Yeah. So you get a dot and then you get a circle, and you just have to put them at the relative distance from each other. You got it. So for part B, it says a heat-seeking bug is put down on a point in XY plane. In which direction should it move to increase its temperature fastest? So when you have a contour diagram, so let's say I gave you a contour diagram. I'll draw one for you. I was going to make one up, right? So let's say I had, let's say the bug was right here. How do you figure out what the steepest path is if he's trying to get over here? The steepest path is going to be the shortest distance between the contour lines. So first he'll go maybe like this, and then he'll go like this, and then he'll go maybe like this, and then what's the shortest distance? Maybe like this. The idea is the steepest path is always going to be the shortest distance between the contour lines. So when you do this one's going to be a lot of concentric circles. You're going to get a circle, and then you might get another circle, and then you might get another circle that's closer together. The idea is, what do you get? It looks like it could be any direction. So if this was, what does he start at? Is put down on a point on the XY plane. So which direction could he go in? So if he went like right here, it's going to be, what direction does he go in if he started right here?
Down.
Like this. But if you go, let's say I placed him right here, what direction do I go in? This direction. If I put him right here, what direction do I go in? Exactly. If you had to describe, if you had to use the same words to describe all of those paths, what would you say?
If extended out, it hits the origin.
Away from the origin.
Away.
Directly away from the origin.
Oh.
Done. Just steepest means contour lines are closer together. That's all it's getting to.